So hello everyone, welcome to this new video. So in my previous videos I had discussed some problems related to linear transformation, right? Linear transformation and matrix of linear transformation. We have discussed few problems and the concept as well. So please recall it and try to understand, because whatever we have studied till now, we will be using those things in the upcoming today's video, that is related to rank nullity operator, okay, or in short it is called as rank nullity theorem. Okay, yeah, let us see what is rank and nullity of a linear operator. Okay, first, rank of t. Okay, rank of any transformation is given by dimension of the image of t is called the rank of t, and nullity of t is the dimension of the kernel of t is the nullity of t. Okay, yeah, so these are the two definitions of rank of t as well as nullity of t. Now rank nullity theorem, what is this rank nullity theorem? Says that, let us see, let v and w be the vector spaces over the field f, and let t be that linear transformation from v to w, that is t tending from v to w. Okay, if v is a finite dimensional, then we can say that according to rank nullity theorem, rank of t plus nullity of t is equal to dimension of v. Okay, if you want to satisfy the rank nullity theorem, this is the condition: separately solve for rank of t as well as nullity of t, knowing the dimension of v. If rank of t plus nullity of t is equal to the dimension of the vector space, then we can say that the rank nullity theorem satisfies in that particular problem. Okay, so this is the rank nullity theorem equation: rank of t plus nullity of t should be equal to the dimension of the vector space v. Okay, for t tending from v to w. So yeah, this was about the some important theory stuff of the rank nullity theorem. So we have two important problems, as I've told you in my previous session at the end of the video. Two important problems. Those two problems are very important and are multiple times repeated in the previous year papers. So you could be studying those two problems as a reference. Okay, so that problems I'm going to solve it now. So this is the first question, rank nullity problems. Verify, very important. Okay, mark it as important. Okay, sure question for 8 marks. Verify rank nullity theorem for the transformation given as t tending from r cube to r cube, defined by t of x comma y comma z is equal to x plus 2y minus z comma y plus z comma x plus 2y x plus y minus 2z. Okay, so this is the given condition, and we should have told us to verify the rank nullity theorem. Okay, first step while solving this problem is we should be finding the basis of nullity of t. To find basis of nullity of t, first you should be taking let v equal to x comma y comma z belong to r cube initially. Okay, such that, observe carefully what I am writing here, nullity of t is equal to v belonging to the vector space v, where t of v would be equal to 0. Okay, so therefore we can say that t of v is 0, so t of x comma y comma z also is equal to 0, right, according to this what we have written. So what is t of x comma y comma z? X plus 2y minus z comma y plus z comma x plus y minus 2z is equal to 0. We are having 3 terms, so add 3 zeros as well here also. Okay, so from this what we would be getting, 3 equations you would be getting, that is x plus y minus 2z equal to 0, y plus z equal to 0, and x plus y minus 2z equal to 0. Okay, we got these 3 equations. We should be solving these 3 equations and checking for the values of x, y and z. Okay, let us see what we would be getting. On solving, First let us write the smaller equation, that is y plus z equal to 0. So we would be getting y is equal to minus z. Okay, this is one term. Since we got y equal to minus z, so what I am doing is, other two equations are there, right? In that other two equations, the value of x and z I am writing in terms of z only. Okay, that is, now consider this term x plus 2y minus z equal to 0. Here substitute the value of y as minus z. So x plus 2 into minus z equal to 0. So x minus 2z minus z equal to 0. X minus 3z equal to 0. So x would be equal to 3z. Okay. And also this final equation, x plus y minus 2z equal to 0. So substitute the value of x as 3z, y as minus z, and 2z you keep it as it is. So we would be getting 3z minus z minus 2z equal to 0. So 3z minus 3z equal to 0, or 3z equal to 3z. So we would be getting z equal to z. Okay, so we got all the values of x, y, z in terms of z only. After that, therefore, write x comma y comma z is equal to whatever answer we got, that is 3z minus z, z, or we can say z, take it common, 3 comma minus 1 comma 1. Okay, so this is the basis of nullity of T. Therefore we can conclude by saying that nullity of T, since nullity of T is the dimension of kernel of T, then we can say that nullity of T is equal to 1. Okay, since we have only one set here, so that's why we could be saying that nullity of T equal to 1. Okay, so in this way you should be solving for nullity of T. So now similarly you should be solving for rank. Okay, how to solve for rank, let us see it now. Okay, now next step is to find basis of range of T. Okay, as 1 0 0 0 1 0 and 0 0 1 belongs to R cube. Okay, it's the basis of R cube. Okay, so therefore we can write it as T of 1 0 0 comma T of 0 1 0 comma T of 0 0 1 belongs to range of T. Okay, this is the range of T. Just add T to this R cube. So we can write it as T of 1 0 0. Solve it separately. That is, they have given the value, right? In the question they have given the set of x, y, z, that is x plus 2y minus z, right? So here x is 1 plus 2y, that is 2 into 0 minus 0, comma y plus z, that is 0 plus 0, comma x plus y minus 2z, that is 1 plus 0 minus 2 into 0, that is 0 itself. So we would be getting our answer as 1 0 1. Similarly for T of 0 1 0, again x plus 2y minus z, so 0 plus 2 into 1 minus 0, comma y plus z, that is 1 plus 0, and x plus y, that is 0 plus 1 minus 2z, okay, that is 2 into 0, that is 0 itself. So here we will be getting 2 1 1. Similarly finally 0 0 1. So again x plus 2y minus z, 0 plus 2 into 0 is 0 minus 1, Then we have y plus z, that is 0 plus 1, and x plus y minus 2z, 0 plus 0 minus 2 into 1, that is minus 2. So we would be getting our answer as minus 1, 1, minus 2. Okay, so therefore we can say that the range of t is 101, 211, minus 1, 1, 2. Okay, so this is the range of t. Okay, now next step is to find the basis of range of t. We should be considering a matrix. Consider a matrix that is A. Consider a matrix A where the coefficients are whatever we got here, the range of t, that is 101, 211, minus 11, minus 2. Okay. Now again, to find the rank, you know the procedure, right? To find the rank, just do the second and third column, third row, first two elements as 0. So R2 with respect to first row R1 would be R2 minus 2R1, and R3 would be equal to R3, already minus 1, minus sign we have, this would be plus R1. Okay. So do that change and write the matrix here. I'll write it here. First row as it is 1, 0, 1. These two elements should be 0. And here now R2 minus 2R1. 1 minus 2 into 0, that is 1 itself. So 1 minus 2 into 1, that is 2. So 1 minus 2 is minus 1. So here R3 plus R1. 1 plus 0 is 1. Minus 2 plus 1 is minus 1. Okay. Now this term you should be making it 0. So R3 with respect to R2 you should be changing, that is R3 minus R2. So if you do 1 minus 1 you will be getting 0, right? So R3 minus R2. So write the changed matrix 1, 0, 1, 0, 1, minus 1, 0, 0, R3 minus R2, that is minus 1, minus of minus 1, that is minus 1 plus 1. Again we get 0. Okay. So from this what we get? Rank of t. Okay, now consider t because we get 1, 0, 1. Consider the non-zero rows 1, 0, 1 and 0, 1, minus 1. Form a basis of range of t. Okay. These two, consider non-zero form, they would be forming a basis of range of t. So we have one more relation, that is dimension of range of t equal to 2, and also dimension of range of t is equal to rank of t. So rank of t would be equal to 2 finally. Okay, so therefore rank of t is 2. Now finally, in order to verify for rank nullity theorem, dimension, they have mentioned it in the question, r cube, right? So we should be getting 3 in order to rank nullity theorem to be verified. So rank of t is 2 and nullity of t we got it as 1 set. So 2 plus 1 is equal to 3. So dimension of vector space is r cube. So it matches here. So we can say that rank nullity theorem satisfied. Okay, so this is the complete problem, guys. Hope it is clear. Please go through each and every step very carefully to find the basis of range of t, rank of t, also the nullity of t. So please do solve it, guys, and try to understand, because this is very important. One question would be definitely asked. Okay, So we have similar kind of one more problem. Let us solve it and wind this session. So this is the one more important problem, repeated many times. Okay. The question is, verify the rank nullity theorem for T. Again, it is from R cube to R cube. Here we can see that the dimension is 3. Okay, keep it in mind. Defined by T of x comma y comma z is equal to x plus 2y comma y minus z comma x plus 2z. Okay. The similar way you should be solving how we solved the previous problem. Let us solve it quickly and see what answer we get. First, in the previous problem we had started from nullity, right? So here let us start first from the rank. Okay, let us first find the rank and see what we get. To find the basis of range of T as 1 0 0 0 1 0 0 0 1 belong to R cube, right? So this is the basis function of this R cube. Okay, so the range of T could be calculated by T of 1 0 0 first, that is x y z values. They have given x plus 2y, right? So x plus 2y first term, that is 1 plus 2 times y, that is 2 into 0. Then y minus z, 0 minus 0. X plus 2z, that is 1 plus 2 into 0. Okay, so we would be getting this as 1 0 1. Next is T of 0 1 0, that is x plus 2y. So 0 plus 2 into y, that is 2 into 1 is 2. Y minus z, 1 minus 0. X plus 2z, 0 plus 2 into 0, that is 0. Okay, so here we would be getting 0 plus 2 is 2, 1 minus 0 is 1 and 0. So finally T of 0 0 1, that is x plus 2y, 0 plus 2 into 0, that is 0 itself. Y minus z, 0 minus 1. X plus 2z, that is 0 plus 2 into 1, that is 0 plus 2. So here we would be getting 0 minus 1 2. Okay, so therefore 1 0 1 2 1 0 0 minus 1 2 belongs to range of T. Okay, so this is the range of T. Now considering matrix, to find the basis, that is consider matrix A in general, 1 0 1 2 1 0 0 minus 1 2. Okay, so here now these two elements you should be making it equal to 0. Here it is already equal to 0, so just consider only the second row, that is R2, change with respect to the first row, that is R2 minus 2 times R1, right? 1 0 1 and 0 minus 1 2, first and third row it is as it is, this is 0, and R2 minus 2 R1, that is 1 minus 2 into 0, that is 1 itself, and here 0 minus 2 times R1, that is 2 ones are 2, so 0 minus 2 is minus 2. So this term we should be making it equal to 0 now. So R3 with respect to R2, that is R3 plus R2, because we have minus sign here, so minus 1 plus 1 is equal to 0. Okay, yeah, so here we would be getting A as 1 0 1 0 1 minus 0 1 minus 2 0 0, R3 plus R2, that is 2 minus 2, again we got 0. So here consider the set of non-zero rows 1 0 1 and 0 1 minus 2 form the basis of range of T. Okay, so dimension of range of T is equal to 2 because we have two sets. So similarly we can write rank of T because dimension of range of T is equal to the rank of T. So therefore rank of T we got it as 2 in this case. Okay, again. So again by solving this step by step you should be knowing it. So rank of T is done. Now let us solve for nullity of T. To find basis of nullity of T, let V equal to x comma y comma z belong to R cube such that nullity of T, just the definition you write, that is V belonging to the vector space V, okay, such that T of V would be equal to 0. Okay, so therefore T of V is 0, so T of x, y, z also is equal to 0 according to the condition. So what is T of x, y, z? X plus 2y comma y minus z, x minus 2z. X plus 2z is equal to 0, 0, 0. So you will be getting x plus 2y equal to 0, y minus z equal to 0, x plus 2z equal to 0. Okay, so now consider this part, y minus z equal to 0, so y would be equal to z. Okay, right, try to find all the terms in term for all the values of x, y, z in terms of z only. That is, consider this equation now, x plus 2y equal to 0, x plus y equal to z, so x plus 2z equal to 0, so x equal to minus 2z. Similarly this term now, x plus 2z equal to 0, so x is equal to minus 2z plus 2z equal to 0, so 2z would be equal to 2z, so z equal to z. Okay, so therefore x comma y comma z equal to x is minus 2z, y is z, z is as it is. Okay, so take z common, you are left with minus 2, 1, 1. Okay, therefore a set of minus 2, 1, 1 is the basis of nullity of T. So since we have a single set here, so therefore we can conclude by saying that nullity of T is equal to 1. Okay, so like this we have got rank of T as well as nullity of C. Therefore dimension of V is equal to rank of T plus nullity of T according to rank nullity theorem. So here the dimension is R cube, rank is 2, nullity is 1, so 3 equal to 3, those are equal, so therefore theorem is satisfied. Okay, so mostly in the most of the cases the rank would be 2 and nullity would become for the dimension if the dimension is equal to 3. Okay, and whenever the dimension sometimes would be equal to 4, that time the most highly the chances are that rank we would be getting 3 and nullity for all the cases it's mostly equal to 1 only. Okay, yeah. So this was the problems related to rank nullity theorem. So please note this down. So that's all for this video, guys. We have one more video left for this module to be completed that we'll see in the next video. Okay, so that's all. Thank you.